We're interested in sketching solutions of a very simple differential equation, x dot equals x squared, which means dx dt equals x squared, with two different initial conditions, one with x of 0 equal to 1 and the other with x of 0 equal to minus 1. This means that we are considering a phenomenon represented by our differential equation x dot equals x squared when it starts from two different positions. One is when x equal to 1, corresponding to t equal to 0 at the initial point, and the other is the position when x of 0 equal to minus 1. And of course, x of 0 represents a path or trajectory that is described by the given differential equation. Now, first thing would be to identify the type of differential equation that we're dealing with, and you are given three options. And the options are whether this differential equation is homogeneous, or it is exact, or it is separable. So with a little bit of workout that we do here, you can easily find out if this equation is separable, exact, or homogeneous. So let's look at the workout. Okay, what we see here is that since dx dt equals x squared, we can rewrite it as dx by x squared equals dt, which means that we have separated the variables x and t on both sides of the equality, and this makes this equation separable. Okay, and now you must know how to solve a separable equation, so I'm just writing down the solution here. And now we check the preview of our what we have written here, if it is mathematically correct. Because the platform of SlvenÄvslve runs under Mobius. So the technology partner with us is Mobius, which is a product of Microsoft that we are using. And once you solve problems yourself up there, you will experience these types of options that you have to work out solutions. So this is a solution that I have found out, and with this solution I insert the first initial condition x of 0 equal to 1, which means that I have to insert t equal to 0 and x equal to 1 in the solution to find out a value of c, which is an arbitrary constant. Okay, so with that value of c reinserted into the solution, I get the solution x of t as minus 1 on t minus 1. And with the initial condition x of 0 equal to minus 1, I should be getting a different value of c when I insert t0 and x minus 1. And with new value of c, the solution turns out to be x of t equals minus 1 on t plus 1. Now all the work has been completed, and now the platform also offers me the option to verify my work. So I'm verifying by clicking how did I do to see if I've done the right thing. And that's the beauty of the platform. No matter how many times you do it wrong, you still have the option to verify your solution, and the system will grade it for you. The next step is to look at the following graphs and find out which of them represent the solution that we have found out with the initial condition x of 0 equal to 1, which means that we have only to find out the graph where x has the value 1 when t is 0, or the graph is passing through x equal to 1. Please bear in mind that the horizontal axis here is the t-axis and the vertical axis is the x-axis, because we are drawing tx graph. So it's not hard to find out, and you can see that one of the graph is passing through x equal to 1, and one of the graph is passing through x equal to 2, and the third graph is passing through x equal to minus 1, corresponding to t equal to 0, and we are interested in the one which has the value x of 0 equal to 1. So we click this one. In the same way, we have three different graphs corresponding to the initial condition x of 0 equal to -1, and you can easily find out that there is only one graph that is passing through x equal to -1 corresponding to t equal to 0, which is this one. The other two graphs are passing through x equal to 0.5 and x equal to 3 corresponding to t equal to 0. And let's also verify our answer as before. Which shows that we have been doing correct work. We are considering another question here in which we have a similar equation x dot equals x times 1 minus x, where x is definitely a function of t. And we want to solve it with three different initial conditions in which one is x of 0 a half, the other is x of 0 1, and the third one is x of 0 as 2. So there are three different starting points of the solution for this particular phenomenon described by this differential equation x dot equals x times 1 minus x. And we will see that we have to undergo the same processes that we went before. That first of all, we have to write the differential equation in the required form where we can solve it. And in this case, you're already told that the differential equation is separable. All you have to do is write it in the separable form where you can solve it either by hand or by using a software. So let's write down the separable form of the equation in the given window. Please do it yourself as well on your pen and paper and see if your answer or your description matches mine, because in the end we will be checking our solutions. Okay, now the solution of the above differential equation, no matter you solve it by hand or using a software, you will get either of the two forms. Either the solution would be x of t equals 1 on 1 plus e to the minus t times c, or the system will multiply the whole thing by e to the t to get e to the t divided by e to the t plus c, where c is an arbitrary constant. Next step, we'll work out the particular solutions for the particular initial conditions that we are given. We insert these conditions into the general solution and we find out the respective solutions for these. So in the first case, our initial condition is x of 0 equals 1 on 2. We insert that into our workout and see what happens. Our solution equation, where x of t is 1 on 1 plus e to the minus t times c, and we plug in the values t equal to 0 and x equals 1 on 2, which is our initial condition. And we see that when x is 1 on 2 and t is 0, then we get the equation 1 on 2 equals 1 on 1 plus c, which means that c should be equal to 1. Now we insert the value of c into the original equation, and we see that the solution would turn out to be 1 on 1 plus e to the minus t. And the same policy applies for the rest of the two initial conditions, and you will see that the two solutions are given as I have written them. Please work it out yourself and see if your solutions match mine. And now we can check our solutions. And the next step is to look at the graphs of the particular solutions that we have found for different initial conditions. We are considering two difficult cases here because x0 equal to 1 is a straightforward case and its graph would be straightforward. So we look at the graphs, and although these days most students use softwares to draw graphs, however, if you want to draw a graph by hand, then you simply have to make a table of values for different values of t that depends on your choice, and find the corresponding values of x from the equation and then draw the graph. And then you can see which one of these matches your graph. If it's still difficult for you, then you only need to see which of the graphs follows the conditions x0 equal to 1.5. Sorry, just a half. So you can compare all these three graphs and you will see that only one of these graphs follows this condition where x of 0 is 1 on 2. The other two have x of 0 equal to 1 and x of 0 equals 2. So they don't match our graphs. And it shows that we are correct. And the third initial condition, which was x0 equal to 2, shows the possibilities of two graphs that can be the solutions, because two of these graphs pass through x equal to 2 when t is 0. And we have to find out which could be the correct one. And for that, we have to look at the solution that we have found. So please go back to the solution that you have found and see whether the graph would look like this one or this one. So let's try this one first and see what the system shows. Okay, it shows that our answer is wrong. Why? Because we have an exponential graph with a different constant than 1. And if we click this one, then the system should mark us right.